Hey hackers and tech enthusiasts, welcome to Protocol, the series where we unravel the history and mysteries behind the technology shaping our digital world. I'm your host Dade, and today we're going to talk about the Internet Engineering Task Force, or IETF if you're looking to save a couple syllables. Founded all the way back in 1986, the IETF is a volunteer-led nonprofit organization responsible for the technical standards that make up the modern Internet Protocol suite. Let's dive in and see how IETF works and how we can get involved. The IETF is broken up into units called working groups, which organize around specific topics. Most of this work happens on mailing lists, which are free for anyone to read or contribute to. You can find these mailing lists on datatracker.ietf.org/wg. Some examples of working groups specific to security include the Web Authorization Protocol, also known as OAuth, Transport Layer Security, or TLS, and Automated Certificate Management Environment, or ACME. But there are over 100 currently active working groups, and each are dedicated to their own area of making the internet better. These IETF working groups are responsible for drafting and standardizing the protocols that all of our systems use, most typically through a process of documents called RFCs. RFCs, the first of which, RFC1, was written all the way back in 1969, began as informal technical notes with the intent of requesting comments from others, hence Request for Comments, or RFC. But these days, they're just called RFCs, and there are over 9,000. Not all RFCs are specifically for protocols, but a lot of protocols are found in RFCs. There are even RFCs that dictate how to write and standardize RFCs, such as 825, aptly named Request for Comments on Request for Comments from 1982. The process for standardizing protocols typically begins with another type of document, called an Internet Draft. These drafts are working documents that are expected to change regularly while in their development, before eventually being submitted as an RFC or possibly being removed. Once an internet draft is submitted, it may then be adopted by a working group to be improved and revised until a rough consensus is met, at which point it may be submitted as an RFC. Rough consensus basically means that the chairpersons of a working group feel that there is a general sense of consensus among the group, though there's no formal voting process, nor is there a formal threshold for what constitutes consensus. To make it easier to determine when rough consensus has been met, and to help ensure that protocols that are going to become standards are more easily adopted, the IETF also favors running code. If there are practical, functional code examples for a protocol, it makes it far more likely to be implemented. And remember, if a protocol isn't implemented by both parties, it can't be used. So this is very important. If you'd like to learn more about consensus in the IETF, there's an RFC for that, RFC 7282. RFCs are frequently iterated on, and as such, they may have been made obsolete by future RFCs. It can be a bit confusing and tricky to navigate these documents, since different parts of a modern protocol may be defined in different documents. Each RFC may mark certain elements of previous RFCs as obsolete or as updated. Consequently, each RFC could be updated or obsoleted by a later RFC. As an example, we can look at the Hypertext Transfer Protocol, or HTTP RFCs. To do that, let's head over to the IETF Data Tracker website and search for it. You'll see that there are a lot of RFCs pertaining to HTTP, but let's start at the first one. Now, bear with me, because this is going to get a little confusing. The first HTTP RFC, 1945, is for HTTP 1.0, and it's classified as informational. This means it was not formally adopted as a standard by IETF, but we'll see that HTTP later does become a standard. With HTTP 1.1, RFC 2068, we have our first IETF standard for HTTP, approximately 7 years after HTTP was initially launched in 1990. This document outlines the majority of how the pages we visit in our browser are transferred from the servers that host them to our devices. We can also see that RFC 2068 was obsoleted by 2616, which itself was obsoleted by 6 different RFCs, 7230 through 7235, several of which in turn have been obsoleted themselves. As you can hopefully see by now, it can definitely be tricky to find the correct information you're looking for in the RFCs, but as hackers, we can often take advantage of that difficulty. We can see firsthand how difficult it is to make sure developers get implementation just right. As we explore specific protocols together in future episodes, we'll see that these standards are often more of a suggestion than a requirement, which further introduces opportunities to find bugs and vulnerabilities. Hopefully now you have an understanding of what IETF is, how it's organized, and how to navigate the documents that outline these standards. If you're feeling inspired, you can even join an IETF mailing list to get involved with the development of a future internet standard. We'll be spending a lot of time talking about IETF protocols in future episodes, so don't feel like you have to start reading the RFCs from front to back today. Do you have a protocol you'd like to see a video on? A protocol you want to know more about? Or maybe a protocol that sounds like it's straight out of Dungeons & Dragons, like ChaosNet? Let us know in the comments down below. If you're interested in seeing more of this series on protocols, give this video a thumbs up and make sure you're subscribed so you can get notified when the next episode goes live. With that, I've been Dade. Stay curious and stay connected.